Hi, Professor. My name is Linh Nguyen. I am a master student of electrical engineering. This is my last semester and I will graduate this fall. After that, I expected to working on the embedded system to design the controller for the drone and, and other non-man device, electrical device. And so I think this class is very helpful for me to learn very basic skill about programming the embedded system. So today I would like to present you my final project on the class embedded system programming. So this is the first when I run my program, the PuTTY screen will show the main menu where we have five different options. Is first option is green LED, hex display, EEPROM, and SD-RAM LCD. And here is waiting for the selection of the user to execute the appropriate action. And on the board, we can see that at the beginning, we can see all of hex 7 hex display is in default case, and because the kit the task 2 is running the kit, so it's running continuously at the beginning, and the on of green LED is on default is on. So first, when the user choose number 1, option 1 green LED, so the sub menu will pop up, and this one they will ask the user what the information, what the green LED to do. So if they choose 1, it means that the green LED number 8 turn on the green LED number 8, and on the software there is a message to send the LED on message and to turn on the LED. And when we hit enter, we see head on, and on the board is the LED is on. So and next, if we turn green again, then we turn to sub menu of option 1 to turn off the green LED. Enter, and now they set the LED off. Here we can see the LED is also off. And let's check the sub menu number 3 of option 1. You can see is select the number 3, option 3, to work on the other green LED. So when we select the number 3, they will pop up a sub option, another sub option. That's ask about the pattern to show the LED, the green LED 0 to 7. So currently the green is on, all the green LED is on, so I want to turn off. So I choose number 2 to turn off. So you can see here the green LED is off. And let's check again. We check in this case, we can check the kit display of the green LED. Number 1 to choose the green LED. Number 3 to select the green LED 0 to 7. And number 3 to display the kit display on green LED. And here we can see the kit display is running. So that is all option of the option 1 green LED. So next, the menu that is come up after this action, they come up to the main menu, and we select number 2, option 2 for the hex display. The hex display, they will ask the what 7 segment display that the user want to show. In this case, we check with number hex 0. And next they will ask the value. So let's see, we can start with number 5. And so now we can see on the hex 0 is show number 5. And because the hex 0 can be controlled by 2 methods, one from the user input, the second one is the semaphore interrupt, bottom interrupt with the semaphore is the bottom 3. So it means that when we hit the bottom 3, an interrupt will be activated. And the interrupt will be post the semaphore, and that will be send the signal to increase the number on the hex 0. As you can see here, when we put it's from 5 to 6 now, and push 7 and 8, 9, 10, A, B, C, D, and then it's go to 0, go back to 0 after that. So this is the hex display, and also the task 4 about the interrupt key 3 interrupt and semaphore. So now we test the option 3 in the main menu about ECE prompt. Number 3, we select. They will ask about 2 action, 2 submenu is about write on the ECE prompt or read. So first we try to write number 1, and they will ask the what kind of address. We start with address 1 and write number 1 on that. So after that they come back to the main menu. We select the 3 again, and now in this case we choose the read ECE prompt by number 2, enter number 2, and they will ask the address. We test the address number 1 that we have just write on. We expected it show on the number 1. So right here they return the data on ECE prompt is 1, so it's what we expected. And now we test the number 4, option number 4 in the main menu is SDRAM. When the user hit 4 and sub menu is come up is about write SEM, write on SDRAM, read on SDRAM, test SDRAM, and DMA test. So if we try to write now, this simply just write. They will ask what data we want to write. Let's see number 9. So this just the data was right at the beginning of the SDRAM, so we don't care about particular address. They will say, and then we try for again to read the data we have just number 2 to read the data. So it will show the data on SD-RAM is 9 that we have just write on. Next we will try the test option, test SD-RAM option. So let's do that by H4 and then number 3 to select the test SD-RAM. And in this case they will pop up 3 other submenu, that is the what kind of test we want. So if we choose, if the user choose 1, they will test all 0 tests. Select true is all 1 test, or if in this case I try test 3 counting test. So it will be the number that write on the SD-RAM will be increased by 1 after each address position. And after that we can see in this case they will return, they will writing on this is check 0 second, because the RAM size of core in this case is only 1024, so it's very short and it can write very quickly. So it's check 0 second to write. And for checking it took about 30 milliseconds to check right here for check counting value. And then we will test the DMA test. The DMA test is to test to compare the copy data method. The first one is copy with the CPU, and the second method is copy with the DMA. DMA is the controller to move, that can move the data from between component to component. So let's choose the SD-RAM at 4, and then we hit 4 for DMA test. So when we hit 4, there are 3 steps will execute by the program. First, they will initiate. They will ask what data. So let's try number 9. So first they will write the number 9 to 1 megabyte block of the SD-RAM, and then they use CPU to copy that 1 megabyte to the second blocks. And then the third step is use the DMA method to copy 1 megabyte to another block. We can see here the first step is check about 0.27 seconds, and to copy with the CPU it take 0.4 seconds, but copy with the EMA it took about 50 milliseconds. It's about 10 times faster than CPU. Yes, because with the CPU, they have to do this for loop, copy one by one data from one address to another address by using the for loop. But in DMA method, they can control and moving the data from the whole block of data from one to another, so it's faster. Now the last task in the LCD menu is in the main menu is the LCD display. So let's see number 5. So they will ask my name, Linh Nguyen, and I hit enter. So when I put my name, my name can show exactly on the LED right here. Yeah, that is all of my work for the final projects. Thank you for your instruction. This is very good. The class is very helpful for me for my future career. Thank you so much, and bye bye.